to cover is section 2.2, talking about circles. And we don't do a ton with circles. We don't do the really hard stuff with circles. We do a very basic understanding of the equation of a circle. And the equation of a circle is written like this: x minus h squared plus y minus k squared is equal to r squared. And inside of that, what you've got is the center of the circle is hk. Like when we did vertex form of the quadratics, hk was the vertex. Here, hk is the center of the circle because that's the important point in a circle, is the center. And then the r is the radius. And if you don't remember radius from geometry or high school math, it's the distance from the center to the edge of the circle. And the key thing here to remember is that radius is squared. So if the radius was 8, then the equation would be equal to 64. So you got to keep that in mind. So the basic premise of the stuff we're doing with circles is taking this equation and then either pulling the center out of it or the radius, or pulling or taking a center and a radius and building the equation from it. Nothing else. So it's really basic stuff with that equation. So let's do a few examples of this. And let's just say it said find the center and radius. And your equation that they gave you this equation, x minus 5 squared plus y minus 3 squared, and said that's equal to 16. And they said, okay, there's your equation. Find the center and the radius for that. So the center is this ordered pair, hk. The x value is always with the x, and it's a minus inside, so you take the opposite of that. So -5 it would be +5, and then -3 would be +3. And that's the ordered pair that's the center of that circle. The radius is this number over here, but remember that's r squared. So we really have to take the square root of 16, which we know is 4. Technically, it's plus or minus 4, but since we're dealing with a circle, you never have a negative distance, and a radius is a distance. So the radius of this thing would be 4, and the center would be 5, 3 out of that. So given the equation, finding the center or the radius or both out of that is what we're after there. Let's do another example. Same instructions, find the center and the radius for this equation. Let's say we had x plus 3 squared plus parentheses y minus 4 squared is equal to 36. So we're doing the same thing. The center, again, going inside of the parentheses there. And remember, it's the opposite of what's in there. So if it's a +3 on the x, that'd be a -3 in the x coordinate of the center. And then a -4 inside of the parentheses turns into a +4 in the center. So -3, 4 is the center, and that's coming from those parts of that equation. And then the radius is taking the square root of this number on the end. If it's a nice square root, go ahead and find it. Square root of 36, we know that that's 6. So the radius is 6 for this one. So always, when we're finding the radius of the circle, whatever the equation is equal to, take the square root of it. And that's going to get you the radius of that circle. And then let's do one more of those. Find the center and the radius when we have x squared plus parentheses y plus 7 squared, and it's equal to 12. So this one, what I'm doing is just trying to show you some different scenarios that could happen that cause a little confusion sometimes. So with this one, you've got a little different looking equation. It doesn't look like it's in the right form, but it is. What they've done is, in disguise, they've put x minus 0 in there. X squared is the same thing as x minus 0 squared. So they're kind of trying to trick you when they do that. So that's really, that's it written in the literal equation of a circle form, is to take those, put the parentheses in there. And that lets you find the center at 0, -7. And then the radius, you're going to take the square root of 12. Well, 12 doesn't have a nice square root. So we've got to do one of two things, or actually we're going to do both. We're going to simplify that square root. So break it down with the factor tree. So 12 breaks down into 6 and 2, 3 and 2, a pair of 2's. So that's 2 radical 3. And then we're going to get a decimal approximation for that as well. Because if we were going to graph this on a we were going to draw the circle actually on the coordinate plane, then we would need to know how long should my line be, because nobody knows what 2 square root of 3 really looks like until you convert it into a decimal and realize, oh, it's only about almost 4. It's not quite 4. So 2, or I'm just going to type in the square root of 12. And I get 3.46. I'll go 2 decimal places with that. So these would be the radius measurements there. 2 radical 3 or 3.46. So if you were going to plot this on the coordinate plane, you put a center, a dot at 0, -7, and then you go almost 3.5 blocks to the left and to the right and up and down and draw a circle, is how that would work. So it's just, the decimal there is really just so we can know how long the radius really is, so that if we had to graph it, we could. Okay. So we've taken an equation and pulled the center and the radius out of it. Let's take the backwards approach to that. So given a center and a radius, let's write the equation. So the reverse of what we've been doing here. So write the equation of a circle with radius of 7 and a center at 6, 8. So again, form for that should be x minus h, y minus k in the parentheses, and then r squared is what it's equal to. So we're just going to replace these things with what they are. So h should be 6, k should be 8, and then the 7 over here is our radius. So we just got to plug them in and crank out the equation. So it'd be x minus 6 squared, y minus 8 squared. And then over here it's 7 squared. And we go ahead and just simplify the 7 squared to make it 49. And there's the equation of a circle based on the information given. Not incredibly difficult, but still something, we've got to you gotta know what you're doing to do it. If you don't know what the equation of a circle is, you're gonna struggle with that. So let's look at another one. Maybe change it up a little bit. Example E. Radius of maybe 3 square root of 6. So an obscure number that really, what's that even mean? And then a center at -3, 0. So a little bit different kind of equation out of that. So again, know the form for, center radius form is what I usually call that. It's standard form for the equation of a circle. But plug it in the stuff where it goes. I mean, you got H and K here, and you got the R. So you just plug those in. So that's going to be X minus -3, and then Y minus 0. And then we're squaring 3 radical 6. And I put that in parentheses on purpose because it makes more sense that way. The only thing left to do is simplify. So we see here in the middle of the first parentheses, you got 2 negatives. Well, a double negative turns into a plus. And then right here, we got Y minus 0. Well, subtracting 0 from something doesn't change it. So we really just write that as Y squared. And then we need to find out what's 3 square root of 6 squared. So no need in really going. I'm going to put it in parentheses in my calculator. That's why I meant to put it in parentheses in there. So 3 square root of 6. Whoops. Press the right arrow key to get out of there. Parentheses. And then I'm going to square it. It's 54. That's what there it is. And we've got the equation of that circle with those kind of exceptional qualities about it, with the radius and the center kind of weird out of that. So there's nothing, nothing too strenuous here. I'm not asking you to take some really long polynomial and do completing the square or some weird thing to get it in center and radius form. It is exactly this is what you're required on the circles to do, is pulling a center and radius form, pulling the center and the radius out of the equation, or taking a center and a radius and building an equation of a circle with it. Those are the skills that we're working on with these. Nothing more, nothing less than that. So very straightforward, specific skill on that. So that's the first section. All right. Let's go to the second section, which goes back into that R3 section. It's like the most common section of the whole course. It's a really large section in your book. Covers a lot of things. So the thing we're going to cover with this section, part of it, is polynomial long division. And everybody loves long division. You did this in elementary school without a calculator, and then you got older and you quit doing it without a calculator and started doing it with a calculator all the time. And that's fine. Polynomial long division is very similar to number long division. I think it's actually a little easier in my opinion than doing that. So what you're given here is you're given 2 polynomials, one divided into the other, long division. That's what it, and they may present it in this form, like x cubed plus 6x squared minus 8x plus 10 over x plus 3. Maybe they write it that way. That's still showing division. It's written as a fraction, but we got to remember fraction just means division. And what we would do is we'd set up a long division problem. And what's on the bottom goes on the outside. And then we do a long division symbol. And what's on top goes in the inside. What you've got to keep in mind is you have to have a representative from every power on inside and outside, starting with the biggest one for that part. So when we're looking at the bottom part, we got x and a 3. So that's x to the first power, and here's the term with no x's at all. So that's got a representative for that. If you were dividing by something that said like x squared plus 3, you would need to put a 0x in the middle. And we'll see an example or two like this in just a minute. But you've got to keep in mind you have to have a representative from each power. So on the top part here, we're starting with x cubed. That's the biggest piece. X cubed. Then there's an x squared. Then there's a plain x. And then there's a no x's. So that has a representative for every power of x, starting with the biggest one. Okay. So if there's one missing, we'll have to put something in its place to keep things lining up the right way. Okay. It's kind of like with the decimals and regular numbers. If there's like not a it's 17.06. That 0 holds the place of that. So if you were trying to divide, you'd have to have that 0 in there. So we got to have that to make it work. So we're going to write that top part inside. And here's how you do polynomial long division. Don't overthink it. It is as simple as it sounds. What you're going to do is you're going to look here at that x. And you're going to say, okay, what times this x would get me x squared? I mean, x to the third. I'll give you the answer. X times x squared gets me x to the third. So I put an x squared up here. Then I distribute. Okay. We look at the leading term. And then don't forget to distribute. So I'm distributing x squared to x plus 3. So x squared times x is x to the third. X squared times plus 3 would be plus 3x squared. Okay. I'm distributing whatever I put up here on the top of the long division symbol. I'm distributing it to whatever's in front, the whole thing. The only part that I look at to decide what goes up here in the top is the front piece. I don't look at anything else. The rest of it is kind of just consequences of what's happening. Okay. So you only look at the first domino. Don't worry about the others. Just knock that first one over. And then I'm going to put this in parentheses and subtract. Because in long division, remember, you always subtracted. And when I subtract there, these first two terms, the x cubed and x cubed, they cancel each other out like they should. That's what we want to happen. And then 6x squared minus 3x squared would be 3x squared. And then we bring down the next term. And again, we look at the leading term outside. What times x would get me 3x squared? It'd be 3x. So I'd put a plus 3x up top. Because 3x times x is 3x squared. 3x times plus 3 will be plus 9x. Okay. So leading term in the front, look at it to decide how much I need to get the next piece. And then I subtract those. 3x squared minus 3x squared cancels out. Negative 8 minus 9 would be negative 17x. That 9 is coming from taking this 3x times that plus 3 there. When I distribute, 3x times x is 3x squared. 3x times 3 is the 9x. Then bring down the next term. I'm trying to use different colors here so that it so you can look at each kind of round separately. And then you look at it and you say, okay, what times this x in the front, the leading term, what times x gets me negative 17x? It'd be negative 17. And then we're going to distribute again. So that'd be negative 17x. Negative 17 times 3, negative 51, parentheses, and subtract. And 17s cancel each other out. Then we end up with 10 minus negative 51, 61. Now, 61 is the remainder here because there's nothing times x that's going to get me something without an x on it, right? I know that I'm done then because there's nothing times this leading term that could get me something without that x on it. So this is the remainder. And when you were in elementary school and you were doing this, a lot of times you wrote, like your answer, like you divided 7 divided by 3, you get 2 and then a remainder of 1. You'd put R1 sometimes. Y'all remember doing that? Like you did 3 into 7, it'd be 2, and then that'd be 6. You subtract, and the remainder is 1. Y'all remember doing that? Well, the way that we want to do it, since it's polynomials, is not with the R, but instead of an R, we're gonna take this, the top part, that x squared plus 3x minus 17, and then we're gonna add 61 over x plus 3. So your remainder goes on the top. What you divided by goes in the bottom. How that relates to 7 divided by 3, remember turning 7/3 into a mixed number? It'd be 2 and 1/3. 2 and 1/3 is shorthand for 2 plus 1/3. That's really what that's shorthand for. Mixed numbers are shorthand for addition. And nobody probably ever told you that growing up. They didn't tell me. But that's what it is. It's 2 plus 1/3 is what it is. So it's your quotient or the answer plus the remainder divided by what you divided by. So you write it as a fraction there. Always going to be what you divided by in the bottom. Remainder in the top. And sometimes that remainder is 0 and you don't even have to put that part there. And that's when something special happens that we'll talk about on Thursday, really. So this is what we're building Thursday's lessons off of. Let's look at another one. Long division is everybody's favorite, so let's do 2x minus 1 divided into 4x cubed minus 8x squared plus 5x plus 6. So this one already written in long division form. I'm going to give myself a little bit more room up top there. So the things we got to check for here are, is there a representative from every power starting with the big one inside and out? So here on the outside, we got plain x and then no x's. That one's okay. Inside, we got x cubed, x squared, plain x, no x's. Cube, squared, 1, nothing. That's the right stuff. Everything's in there that I need for this one, okay? So again, I'm going to go through the long division, so I need to look at the first term on the outside. So I look at this 2x. What times 2x would get me 4x cubed? Good. 2x squared. 2x squared. And then what do we do with that 2x squared? Distribute. Distribute to the stuff outside. So 2x squared times 2x squared is 4, or 2x is 4x cubed. 2x squared times a minus 1 would be minus 2x squared. Parentheses, subtract. Always parentheses and subtract. X cubes cancel out. That's what should happen every time. If it doesn't, then you didn't have the right number up top, or you mismultiplied. And then -8 minus -2 be -6x squared. Bring down the next piece. What would be the next thing to go up top? Yeah, -3x. Because -3 times 2 is -6, and then x times x is x squared. So that's -6x squared. -3x times -1 is +3x. Parentheses and subtract. X squareds cancel. 5 minus 3 is 2. Bring down the +6. All right. And then the next thing to go up top, +1. Yeah, just 1 times 2x gets me 2x back. So that's easy. And then 2x times -1 is -1. Parentheses and subtract. X's are gone. 6 minus -1, 7. So we'd have 2x squared minus 3x plus 1 plus 7 over 2x minus 1. Finding that remainder and putting, just, it's always going to be a plus and then over whatever you divided by is what you want that to be. Long division, one of these things, you're not going to use it all the time, but there are some very specific times that you're going to need it. And if you don't know how to do it, you're stuck with the problem, and it comes up in 110 again with that. So it's one of those skills, you don't use it a ton, so you got to kind of catch it now and kind of store it back. And it's like, okay, I don't use the 9-pound sledgehammer a whole lot, but it's good to have when I need it to knock out a wall or whatever. So it's one of those skills that you just got to hang on to. We're going to do one more of those, and let's get one that's got a few exceptions to it that we got to be careful of. So let's take 3x cubed minus 2x squared minus 150 divided by x squared minus 4. So written in a fraction form there, but we know that means divide. And that means I'm going to do some long division here. In 110, you'll do a whole section about functions that are written this way, and one of the things you'll have to do is long division to kind of guide you in being able to get some of the pieces that you'll need for that. So setting up the long division, if you don't set it up right, doing it right is I won't say impossible, but improbable for sure. So when we're setting this one up, we look at the what's going to go on the outside. And what's going to go on the outside is the x squared minus 4. And we need a representative from every power. So what do I have to put in there so that I've got a rep for every part? Yeah, I'm going to put an x squared, and then I'm going to put plus 0x in the middle, and then a minus 4. That's some people, if you watch some Khan Academy videos or you go YouTube and type in polynomial long division in there to try to find some videos, there will be people that don't put that on the outside. And that's okay. It can be done without doing it. But I think it helps keep things in line if you put it on the outside as well. Everybody, though, puts it on the inside. So on the inside, what do we need to put in there? We got the 3x cubed. We got a minus 2x squared. But it's missing the plain x as well. So I need to put a plus 0x in there. And I always use a plus sign there. Never use a minus sign when you're putting that 0 in there, just because it introduces a negative sign that you don't really need. You don't need that kind of negativity in your life, as they say. So don't put a negative 0x in there. It's no such thing. Just put a plus 0, whatever you need in there. Okay. Once you've got it set up correctly, it's the same process as far as doing the division. You look at the front piece and say, okay, what times x squared is going to give me 3x cubed? Be 3x, wouldn't it? 3x times, and I noticed I put that on top of the column. It's like there's columns for every power of x in my problem. So I put the 3x over the plain x column. 3x times x squared, 3x cubed. 3x times 0x would be 0x squared. 3x times negative 4 would be negative 12x. Parentheses and subtract. So I'm just distributing 3x to everything on the front. 3x times x squared is 3x cubed. 3x times 0x, 3 times 0 is 0. X times x, still x squared. And then 3 times negative 4 is negative 12, and then has the x on it. And then I subtract those. These cancel like I want to. That first term should always cancel. And then I'm going to subtract. Negative 2 minus 0 is still negative 2. But then 0x minus negative 12 be plus 12x. Got to be very careful with signs on this. And then I'm going to bring down the last term. Always bring down that next term out of that. So this one, a little longer looking problem, but it's going to be shorter, it seems like, with our how much work we're having to do, because we get to the answer a little quicker. And then what times x squared is going to get me negative 2x squared? Well, all I need is a negative 2. Negative 2 times x squared is negative 2x squared. Distribute. Parentheses. Subtract. So negative 2 times x squared is negative 2x squared. Negative 2 times 0x would be 0x. Negative 2 times negative 4 would be positive 8. And I'm subtracting those two. So again, the x squareds are going to cancel. 12 minus 0 is 12. X. Negative 150 minus 8 would be negative 158. Now, this remainder looks different because it has an x in it. But you've got to think, okay, I know I'm done. I know that's the remainder. because this piece, this x, is smaller than that leading term. Okay, I have x squared here. I couldn't multiply x squared times anything and get 12x, anything logical anyway. Okay, so my remainder is 12x minus 158. So when I write my answer, it's going to be 3x minus 2 plus 12x minus 158 over x squared. And I'm just going to shorten that up and say x squared minus 4. Because I really don't have to have that 0x in the middle when I'm writing my answer out of that. So I'm going back to that original, what was on the bottom of the problem. So that's my remainder there with that. So keys to long division are: make sure you're in descending order and you've got a representative from every power of x on outside and inside, starting with the biggest one for each piece. So start with the biggest one on the outside. Make sure you got a power for x all the way down to none. And then on the inside, look at the x's. Start with the biggest one all the way down to the smallest one, or the no x's, and make sure you got a representative from those. If you don't, put a 0 in there. It helps keep things in line for the long division out of that. And the more you kind of line yourself up and make the columns line up, the better. Organization's a key to getting the long division correct out of that. All right. All right. Well, let's get to that last section of the day. Believe it or not, it'll be a shorter day today, but this last section is a little bit more intense than the others. All right. So section 3.2 is about synthetic division. And then the factor and remainder theorem. They're very much related, okay? Synthetic division, factor and remainder theorem, okay? So synthetic division, kind of help kind of define it. It's division, but you might see it called synthetic substitution. Can be used for linear divisors. Only. Linear divisors are things like x plus 3, 3x minus 7, 6x plus 11. Those things are linear divisors. They don't have an exponent on the x. Okay, synthetic division can be used then. If you're dividing by something that has an x squared or an x cubed or something like that, you can't use synthetic division. You can only use linear pieces for synthetic division. Okay, linear divisors. And synthetic division or synthetic substitution is a different way of plugging in a number for a function. Okay, so what we're doing is basically, if we're asked to do synthetic division for let's say a -3, it would be like plugging -3 into a function and working it out. The difference is that synthetic division gets you the polynomial divided by something, where substitution, where you're just plugging in the -3 and working it out, only gets you a number answer. It doesn't get you what happened to the polynomial when you did that. So synthetic division, very useful. It's going to be, like I said, this section ties really tightly into what we're doing Thursday. So this is the thing you really need to practice a little bit between now and Thursday, so that you've got some understanding of how synthetic division works, so that when we start trying to take a polynomial and break it into all of its little pieces, you're not lost in the synthetic division part, because the synthetic division part is supposed to be the easy part of that. So we're going to learn how to do synthetic division or synthetic substitution, and then what does that mean as far as a factor and remainder theorem goes. Okay, so the first one we're going to do, example A, is 5x cubed minus 6x squared minus 28x minus 2 divided by x plus 2. Okay. So looks just like long division, fraction type problem. When we see that, we want to look at it and say, okay, can I do synthetic division? It's easier than long division. Can I use it on this one? And you look at the divisor. What are you dividing by? You're dividing by x plus 2. That's linear. So that's what allows you to use synthetic on this, is that it's got a linear factor or a linear divisor there, x plus 2. So what you want to do then is set up that. So to set it up, you've got to find out, what am I dividing by? So you set x plus 2 equal to 0 and solve it. So whatever's in the bottom, set it equal to 0, solve it. -2. That right there is what we're going to divide by in synthetic division. Okay. Here's how I set up my synthetic division. Draw yourself this little L flipped over and laying down. And I usually take 2 lines on a piece of notebook paper if you're using lined paper. The top line is going to be the coefficients. The bottom line is going to be what I'm going to write in extra. And then over here on the left-hand side, on the upright, I put a little shelf there. On that little shelf is that number there. That's what I say. On the shelf goes a -2. Notice I didn't put an x on that. I just put the -2, whatever x was equal to when I solved it for equal to 0. On the top row in here, I'm going to put the coefficients, the numbers in front from that polynomial. Okay, so I've got the 5, a -6, a -28, and a -2. It's like 4 separate columns, basically. But it came from that polynomial. If there was a missing piece, like there wasn't an x squared, I would put a 0 in that spot. So I've still got to have a representative from every power, just like I did with long division. But this time I don't have the x's in there to deal with. Okay? X's are gone with synthetic division. Synthetic division just gets you working with the numbers. That's the synthetic part of it, that there's no x's in there. Okay? Now, what do we do with that? Here's what we do with that. Drop the 5 down to there. Then you multiply. Whatever's down here in the bottom, multiply to the shelf. 5 times -2 is -10. Okay. Then we add. -6 plus -10, -16. Then you multiply to the shelf again. -16 times -2, +32. And then you add. -28, +32, +4. And then you multiply to the shelf again. 4 times -2, -8. Then you add 2 plus -8. -2 plus -8 be -10. There's not another number out here, so you stop there. Okay? Always, you drop the first number down and then multiply and add. Multiply and add. Multiply and add. Always. In synthetic division. There's no subtraction in synthetic division, which makes it easier. Subtraction always kind of messes things up when you got positives and negatives and all that. Subtractions adds another negative, so it makes it harder. So you're only going to add in synthetic division, multiply and add, multiply and add. Now, here's what it does for you. What this tells us is that that negative 10 is the remainder. This here, these are the coefficients of the polynomial, the quotient. So here's what it builds. It builds a 5x squared minus 16x plus 4 plus negative 10 over x plus 2. That's what we've done. When you do synthetic division, it always reduces the power by 1. Okay, so we had x to the third to start off with. We end up, when we divide that, we end up with an x squared. So it makes it go down 1 every time. And that's because x cubed divided by x, it cancels out one of the x's. That's what happens with the linear factor or linear divisor. It's going to reduce that power by 1. That's going to be important on Thursday.
So that means every time like that should look like an x squared, x squared.
If it starts with an x cubed, yes. If it starts with x to the 4th power, then it'll be x cubed, x squared. It does go in that order, but it's always just going to reduce that power by 1. Whatever you start with, reduce it by 1. The last number is always your remainder. And then the rest of it are your coefficients from there. And we'll do an example that's a little different next and see how it reduces it by 1. Okay. Now, again, that's our remainder. Here's what would have happened. Synthetic division is the same thing as substitution. If we had plugged in a negative 2 into this top part and worked that out, we had 5 parentheses negative 2 to the 3rd power minus 6 parentheses negative 2 squared minus 28 parentheses negative 2 and then minus 2. I get negative 10 when I plug that in. So that's why it's also called synthetic substitution. You get the number that's the remainder, but by just plugging it in, we don't get the polynomial part that resulted in the division. Okay, so then synthetic division is the same thing as substitution. That's also going to be an important part for Thursday, is that fact that plugging a number into a polynomial tells us what the remainder is going to end up being. And that's an important part. That's what part of the factor and remainder theorem we'll talk about in just a second means. Okay, so knowing what the remainder will be is the same thing as plugging it in to the problem, but you miss all the polynomial part by doing that. And the polynomial part is what we need. Okay, so that's why we're having to do synthetic division this way. All right, so let's look at another one. Let's say we had negative x to the 4th plus 3x squared minus 4x minus 5 divided by x plus 3. So writing the problem just a little bit differently as far as that goes. Nothing fancy about that. It's actually, old school, way of writing the division problem. So we look at what we're dividing by. We're doing synthetic division because this is a linear factor, a linear divisor, x plus 3. It doesn't have an exponent on the x. That's why we can do synthetic division. And synthetic division is easier than long division because you don't have to deal with all the x's and multiplying x times x fourth and x cubed and all that stuff. You don't have to worry about that. All you got to worry about is numbers. Okay, so I'm going to set up my synthetic division jig here. What goes on the shelf for this one? Yeah, it'd be negative 3 because when you set x plus 3 equal to 0, you get x equals negative 3. So it's always just going to change that sign and be the opposite. So we're going to use a negative 3. And then we're going to put the coefficients of our polynomial we're dividing into on the top row here. So that'd be -1. And then that's x to the fourth. The next piece they tell me is x squared. So I'm missing a piece. I'm missing an x cubed. So I've got to put a 0 in its place. The 3, the -4, and the -5. If I don't put that 0 there, it will not work correctly. Okay? You can get some numbers, you can get all kinds of stuff, and they will be wrong. If you don't put that 0 in the place of the x cubed, things will not go well. So we're going to take the -1. That first piece, you're always just going to drop it down. That gets the ball rolling. So then we say -1 times 3, or times -3 is 3, and add. Multiply. 3 times -3 is -9, and add. 3 plus -9, -6. Multiply. -6 times -3, 18. Add. 14. Multiply. 14 times -3 would be -42. And then add. -47. That, again, that's our remainder. Let's put an R there. That's our remainder. Okay. So on this one, we started with an x to the fourth power. So when we run synthetic division the first time, it's going to, instead of being x to the fourth, it's going to go one less. So it's going to be x to the third that we start with. So our first term would be -x cubed. And then we just trickle down from there. 3x squared minus 6x plus 14 plus -47 over x plus 3. And we've done the polynomial division using synthetic division instead of long division. If you wanted to do long division, you should get the exact same answer. I've never had anybody that wanted to do the long division if you had a choice. And you definitely probably don't want to do long division. When we start breaking down polynomials on Thursday, the synthetic division you're going to do multiple times. So it's quicker, much quicker than the long division is, because you don't have to do the parentheses and subtract and all the x's and all that stuff. So it gets rid of that stuff for us, which is nice. Makes it a lot easier. Okay. All right, so we kind of got the idea of what synthetic division is. So let's use it to try to decide if something is a factor. And that's where the other part of the title of the lesson comes in. And that's the factor and remainder theorems. And I'm not going to give you the big, long official theorem of this. If you want to read it, it's in your textbook. I'm going to give you the long and short of it. I mean, this is what the factor and remainder theorem tells us, that if the remainder is 0, then the divisor is a factor of the polynomial. And this is where it leads into what we'll do on Thursday, is that the value on the shelf is also a 0 / root / x-intercept for the polynomial. Okay. So if the remainder is 0, when we do the long division or we do synthetic division, we're going to use synthetic because we're going to be dividing by linear pieces. If that remainder is 0, then that divisor is a factor of the polynomial. It also means that that value that we put on the shelf is a 0, which means it's a root or an x-intercept. Those are all three words that mean the exact same thing for that original polynomial. Okay, so when we're 2 weeks ago when we were in class, we talked about factoring polynomials, and we factored x squared problems, quadratics. We did the x method for factoring there, and that's great. And we also did sums and differences of cubes. What this allows us to do is take a much larger polynomial, something that's x cubed plus something x squared, like what we've seen in the problems that we've done division with. Take that really large polynomial and start factoring it into its individual pieces. So this synthetic division that we're going to be doing and checking the remainders is going to allow us to start breaking a polynomial down into its individual components. Okay, so we're going to take a large polynomial and break it down using this particular tool of synthetic division. So let's look at a few examples of this and kind of how they can present the problem. So is x minus 1 a factor for f of x? That's the question we're going to answer. And our example for this one, f of x is going to be x cubed minus 4x squared plus 9x minus 6. I wrote another 9, minus 6. Okay. That's our polynomial. And we're going to decide, is x minus 1 a factor of that polynomial? Okay. The way to decide that is to do synthetic division with that polynomial and x minus 1. So set up synthetic division. Okay. What goes on my shelf for synthetic division? Positive 1. It's always going to change signs. So it's x minus 1. It's going to be a positive 1 that goes on that shelf. And then we put the coefficients of that polynomial inside there. So 1, negative 4, 9, and negative 6. And then just run it through there with the 1. So drop that first term down. 1 times 1 is 1, and add. It's negative 3. Multiply. Negative 3 again. That'd be 6. 6 times 1, 6. Hey, there's that remainder. What's that remainder? 0. Okay, what that means, x minus 1 is a factor of f of x. It also means x equals 1 is a 0 of or for f of x. Okay. And we'll use that a lot on Thursday as far as what that means to be a 0. Okay.
What is this? I'm confused on what this second part is. X equals 1 and 0.
Yeah, that's an added bonus to the thing. We're answering the question, is x minus 1 a factor for f of x? And the answer is yes, because that remainder is 0. But also because that remainder is 0, that it means that x equals 1 is a 0 for the polynomial or an x-intercept for the polynomial. So if we were to graph this polynomial with our graphing calculator, we would see it crossing the x-axis at +1 because of all of this stuff that we just saw happen with synthetic division. So let's look at the factored form of this, and that's kind of a key, the factored form. What that does for us is it breaks down that polynomial one degree. So we went from x cubed to now this line is x squared. So that's x squared minus 3x plus 6. And then we've got the factor x minus 1. That would allow us to try and break down this quadratic by factoring, if possible. And this one doesn't factor. And, I'm not exactly in, today you're not going to have to break it down all the way. Thursday we are going to break it down further. But the factor, when you factor that, we got x minus 1 is a factor. So you got the parentheses, and then you got what the quotient is the other parenthesis there. That's the factored form of that. That's what that builds for us. It's taking that polynomial and splitting it apart. We're breaking it down and getting it into its individual pieces. And those are its individual pieces for right now, this polynomial. All of that stuff. When you see this on the lab or the exam, it's going to say, is this a factor? And it'll be a yes, no type thing, and or what's the remainder? And you would tell that. All of these things are possible parts of an answer to a question. They're not going to ask you probably for all three of them. That is it a factor? What's the remainder? Or what's the factored form? They're not going to ask you for all three of those, but they could ask you for any one of those. And so knowing that they're all related, you do the same work to get any of those answers is what I'm after here, what I'm trying to present to you. That if I do that synthetic division and the remainder is 0, that means it's a factor. So that's a yes on that. If you get the remainder of 0, that means the factored form is going to be this quotient, x squared minus 3x plus 6, times that factor that we got. That's the factored form.
If the remainder is not 0, you just write it the way we were before.
Yeah, if you write it, if the remainder is not 0, then it's not a factor. That's exactly right. Let's look at maybe something that give you that example there. Example D. F of x equals x to the 4th minus 2x cubed plus 4x squared plus 2x minus 5. That's our polynomial. We want to know is k equals -4 a 0 of f of x. So this is a different way that they're presenting the problem. They might present the problem is they give you a polynomial and they say, okay, is k equals -4 a 0 of f of x? They didn't say is x plus 4 a factor. They said is k equals -4 a 0. Okay, so this is a different way of presenting the problem, but it's the same work. That's what I want you to get out of this, is that it's the same work. It's just presented in a different way. Okay, so what we would do here is synthetic division. 1, -2, 4, 2, -5. And then on the shelf, because they gave me something that said k equals -4, I'm going to use -4 on the shelf. Because they're giving me what the 0 is, not the factor. That's the difference in example C and D. C, they gave me the factor, and I had to get it equal, change the sign. Since they gave me here something that's equals, I don't change the sign of it. And then I run that through with the synthetic division and look at the remainder. This is a yes/no question. Is it a 0? If it's not, if the remainder is 0, then it's yes. If the remainder is not 0, it's no. drop down the 1 and multiply and add. 80 and 32 be 112. Oh, me. 440. And then be 435. Is that a 0? Big fat no. K equals -4 is not a 0. What I want you to understand is that the same problem could be asked in this way, that it might say, is x plus 4 a factor of f of x? Though this question and this question require the exact same work. There's no difference in the work involved to answer those two questions. They're both, the answer to both of those questions is no. But the work to get the answer is exactly the same. Okay? Those two questions are the same question as far as what kind of work you need to do. The answers to them are the exact same. Both are no. But the work came from the synthetic division with the -4. So that's what you've got to, that's one of the things that the work is not really that difficult here. It's just multiplying and adding. But you've got to know, okay, what do I do here? What do I use, the negative, the opposite of this sign, or do I use the same sign? And that's based on how they ask the question. Okay. Let's look at, yeah. If it says, if it asks you for something and has an equal sign, like K equals, then then you leave the sign on the shelf the same. That's when the sign is the same. But if it asks it in factored form, that's when you take the opposite. We're going to do a few more examples, and I'm going to mix it up so that we can make sure we know which way to work it. Okay. Let's look at this one. Is x plus 1 a factor of f of x equals x to the 4th minus 2x cubed plus 4x squared plus 2x minus 5. So this one, they gave us, it said the word factor, and they gave us something that had x plus or x minus something in it to check with. So when we do our synthetic, what do we have to remember about the number on the shelf? It's the opposite. So what number is going to be on the shelf here? -1. Because it was in factored form. The x is asking about a factor. So we swap the sign. And then we put in the polynomial the same way. Drop it down. Multiply and add. Hey, I got 0. What's that 0 mean? X plus 1 is a factor. So the answer is yes. What's it mean? So I'm going to add a question to this. what does this mean for x equals -1? X equals -1 is a what for the polynomial? It's a 0 for f of x. It's a 0. It's an x-intercept. You might also hear it called a root. Those are all the same thing. That x equals -1. That because x plus 1 is a factor, that means that it is that x equals -1 is a 0 for the polynomial. And that it's not anything. You know, they are related. Those things don't happen, then it's not a 0. Okay. Write f of x in the factored form, so that'd be a different question. The same work would have taken to get there. You'd have your f of x, and then you'd have x plus 1 is the factor that we used, and then x cubed minus 3x squared, 7x minus 5. There would be the factored form to answer that question. But it took the same work to get there as answering the question, is it a factor? So I didn't have to go back and rework the problem a different way. It's the same work to get all of those 3 different questions answered. It's the beauty of synthetic division, that it does several things based on what that remainder is. So let's say we would have example F. Is k equals 1/2 a 0, or yeah, for f of x? And I don't need more room to write f of x because it's kind of long. It's actually the same one we just used. X to the 4th minus 2x cubed plus 4x squared plus 2x minus 5. All right. So got a fraction introduced here. Fractions work inside synthetic division just like regular numbers do. Okay. So still the same question, still the same work. Okay. Is that a 0 of that? So that means I'm going to do synthetic division. I'm going to draw this one a little taller because I'm going to have fractions involved. On the shelf, what's going to go on the shelf here? Positive 1/2. Not going to change the sign this time because it's k equals. It's the 0. And then we're going to, throw the coefficients up there. A little bit more difficult here because you got fractions to deal with. Do not change them to decimals. If you do change them to decimals, do not round them at all. Because if you round, it will mess things up. Okay, so I'm going to leave them as fraction forms. I'm going to use my calculator to help me. No, nothing says you can't do that. But what I'm saying is, don't change them to decimals because it could cause some problems in rounding error that would make your remainder not be the correct number. Okay, so drop the 1 down. That's easy. Then it gets more difficult. So I'm just going to use -2 plus 1/2. And I'm going to hit math, enter. negative 3 over 2. And I'm going to multiply. Negative 3 over 2 times 1/2. Math. Negative 3/4. That's what goes here. I'm going to add that to 4. I'm going to change it back to fractions. 13 over 4. And then I've got to multiply that times 1/2. So it'd be 13 over 8. So 13 over 4 times 1 over 2. Math, enter. 13 over 8. That's what I wanted. Then I'm taking 13 over 8 plus 2. Math, enter again. 29 over 8. Okay. Multiplying that times 1/2. 1 times 29 is 29. 2 times 8 is 16. You can do that with a calculator easily, anything there. Now, I'm definitely going to do that addition with the calculator. Negative 5 plus 29 over 16. Math, enter. Negative 51 over 16. Hey, and I've reached the place at the end there. That's the remainder. What does that tell me about 1/2 and this polynomial? It's not a 0. That's what that tells me. It also tells me that x minus 1/2 is not a factor. That's the bonus information that I get. That's not a question that was asked for the problem, but that's information that I know because of the way the synthetic division worked out. Okay. All right, let's do, we worked with imaginary numbers or complex numbers in quadratics. Complex numbers are still part of polynomials. So complex numbers can work in synthetic division as well. And that's one of the beautiful things about this, is that complex numbers can work in it as well, because finding those complex zeros can be difficult sometimes. So example G. Is k equals 1 plus 2i a 0 for, and I'm going to again put f of x down here at the bottom. F of x equals x to the 4th minus 2x cubed plus 4x squared plus 2x minus 5. You notice I'm using the same polynomial. All these examples here. So again, setting up synthetic division. I'm going to spread this one out a little bit longer because it's got the complex numbers in it. But what goes on the shelf here? Yeah, 1 plus 2i. Not changing the factor there. It's k equals. So it's giving me the 0 and asking me to work it out. So I'm going to put the coefficients over here, 1, and I'm going to spread them out a little bit. Negative 2, 4, 2, and negative 5. Spreading those out because I got the complex numbers, and I'll probably, the one I'm dividing by has 2 terms, so I'm going to assume that every one of them after that's going to have some 2-term stuff in it too. Okay. the work is the same even though that's a complex number. It doesn't make it different work. It's the same work. You still drop the 1 down and then multiply. The difference is that you're multiplying 1 times 1 plus 2i. So it's like distributive property. 1 times 1 is 1. 1 times 2i is plus 2i. And then you're just adding from there. And this is where it gets a little bit more difficult because you got to be careful because you're adding negative 2 to 1 plus 2i. So negative 2 plus 1 is negative 1 plus 2i. Now you've got to multiply negative 1 plus 2i times 1 plus 2i. So 1 plus 2i times the negative 1 plus 2i. And here's where, you could do this by hand if you wanted to. Remember, our graphing calculators will do this for us if you want to use that feature where you would take parentheses 1 plus 2i and then negative 1 plus 2i and multiply those together and get negative 5 is what we end up with. So that's what goes up here. If you did that by hand, it's just distributed property twice. 1 times negative 1 is negative 1. 1 times 2i is plus 2i. And then you distribute the 2i, that'd be negative 2i. And then there'd be 4 times negative 1. So that's where these i's cancel out. And that's where it's negative 5. That's where that's coming from. I'm doing it, I did it with the calculator, but the great thing is once you've done that part, now it's back to regular numbers. 4 times negative, or 4 plus negative 5 would be negative 1. And then that multiplication's a little easier. Negative 1 minus 2i. That ends up being 1 minus 2i. When you subtract, or you add those two, 2 plus negative 1 is 1. And then the minus 2i just comes down with it. And then you've got to multiply 1 minus 2i times the 1 plus 2i. So 1, whoops, I forgot the parentheses. 1 plus 2i times 1 minus 2i. Positive 5. Bless you. And that's what goes up here. And hey, look at that. Got a 0 for the remainder. So that tells me that k equals 1 plus 2i is a 0 for f of x. Well, yes. That'd be the more official way of writing that would be yes out of that. Taking a complex number and running it through with synthetic division. Possible. A little bit more difficult, but don't forget, the tools you have. You got a calculator that can help you with those and a few, other things that really can make that a little easier on you. But we're really after, is it a 0 if it asks about it, if it's k equals, or is it a factor if it says, has the x plus or x minus something? Is it a factor? It's the exact same work. Synthetic division, what's the remainder? The remainder is 0. The answers are yes. If it's not 0, then the answers are no. It's not anything, not a trick to it from there. Let me pick one from the book here and work a couple more examples of this just to get you a little bit more comfortable with it. Let's say we had example H and let's do this one. Is k equals 1 a 0 for f of x equals 2x cubed plus 9x squared minus 16x plus 12. So that'd be synthetic division, obviously set up 2, 9, 16, negative 16, and 12. And then 1 on the shelf. And then you're just running it through with your synthetic. -5. Is that a 0? No. Do another one with the complex, with a imaginary or complex number in it. I think those are maybe the most confusing because it's just different to work with that complex number. Okay. So your synthetic, 2i on the shelf. Now here's what we got to be careful about with the x squared plus 4. You got a 1, and then there's not a plain x, so you got to put a 0 in the place of it, and then the plain number 4. So you got to put a representative there for that. Big deal for that one. And then, run through there, drop the 1. That's 2i. Well, that's just 2i. And then 2i times 2i be 4i squared. And I squared is -1, so that's actually -4. So the remainder is 0. So yes. All right. Let's see here. Let's do one more here. Let's say express f of x in factored form let's say we had f of x equals, let's do x cubed minus 4x squared plus 2x plus 1 with factor x plus 1. So when I set up my synthetic here, 1, -4, 2, 1, what goes on the shelf? I'm going to change the sign because they gave it to me in a factored form. So that's -1 on the shelf. So, and run that through with synthetic. and see. That'd be, that should have been a 7 there instead of a 1, guys. I'm sorry. I miscopied the problem. Make that a 7. That's what it should work out to be. All right, so there's a remainder of 0, like we need it to be if it's a factor. And the factored form, it says express it in factored form. So factored form, we got the x plus 1 that we used, and then we get x squared minus 5x plus 7. And that's from these coefficients here. There's the factored form they're looking for. If that remainder wasn't a 0, then this piece would have the plus r over what you divided by. It'd be like what we did with the long division. It would look that way. Okay. Okay. Let's do one more with a fraction in it, so we can get some practice with those, and then we'll call it a day. Believe it or not. Let's say we had is k equals 2/5 a 0 for f of x equals 5x to the 4th 2x cubed minus x plus 3. So this one, checking a 0, so sign doesn't change on the shelf. 5, 2, 0. Be very careful. Make sure that you put a representative in there for the x squared that was not in the problem. If you don't, it's not going to work correctly. You might get a false report that it's a 0, or you might get that it's not a 0 even though it really is. If you don't put that 0 in there, it's going to mess the problem up in some way. So not very likely that you could make the right mistakes to make it work out the same. Okay. Drop down the 5 and multiply away. So 5 times 2/5 would be 2. I think 5 times 2/5 is 2. And then add 4. 4 times 2/5. 4 times 2/5. 1.6. I'm going to change that back to a fraction. 8 over 5. Well, that's easy addition. That's 8 over 5. And then multiply those two together. Be 16 over 25. 2 times 8 is 16. 5 times 5 is 25. And then negative 1 plus 16 over 25. Inner. Negative 9 over 25. And that times 2/5. Negative 18 over 125. Which is obviously that remainder is not 0. I'm going to go ahead and find what it is. $357 over 125. 357 over 125. But that tells us that the answer to our question is no. So you can get a polynomial 0. If you get a 0 in the remainder, it is a 0. If you get a 0 in the remainder, then that means you have a factor from that. All of those things related to exactly the same work. Nothing is different about how you do that. Okay. So things for this week, we've got labs. I'm going to get the videos for those done in just a little bit and get those posted on YouTube. And so make sure you watch through the videos before you work the labs. It'll help you, I promise, on these, especially because the labs are the way it asks the question, especially on the synthetic division part. So there's 3 labs from the day. There will be 2 labs next for Thursday, and then that lab 27, which is the practice final, which everybody should get 100 on that anyway. So no, it's not. You don't have to turn in lab 27 to me because it's a practice final. It's there for you to practice. I'll still record the grade for it. Everybody gets 100 on it because you got the key. But as far as that goes, you don't have to turn that in. But you will need to labs 22, 23, 24, 25, and 26 are all due next Thursday before the final. And we'll have class Thursday, 9 o'clock. We'll meet. We'll go through those 2 sections. It'll probably take us as long as it did to go through these 3 sections for those 2 sections, maybe a little bit longer. It's a little bit more involved stuff with the polynomials and breaking them down further and further as we go, and then looking at some graphs as well. So that'll be kind of handy to have your graphing calculator because I'm gonna show you a few shortcuts with it on the polynomial breakdown stuff, especially with the graphs. There's some shortcuts we can take. And then exam 4 will be due next Wednesday night, midnight. Final is Thursday morning of next week, the 6th. And again, it's just getting ready for that. Make sure you come in prepared. On the answer document, you'll have formulas and things. I'll give you some of those as far as that goes. And then we'll talk Thursday. I hadn't decided on some other stuff yet on that final. It is timed though, so that makes all the difference in the world sometimes because a little bit of pressure sometimes. If you got questions on the labs or any work or anything we're doing, feel free to email me. I'll get back to you as soon as I see it and try to get you what you need out of that. So email me if you got questions. Other than that, you're dismissed for the day. I appreciate it, guys. 22, 23, 24, 25, and 26 will be due next Thursday. Not this coming Thursday, but the next. It's 22, 23, and 24 or go along with what we did today.